Good morning, everyone, and welcome to this lecture. This is lecture number 9, and we are dealing with impulsive forces. In the last lecture, we had seen what is an impulse and what are impulsive forces. Impulse is the integral of f dt, and we have seen that impulse is nothing but change in momentum. If the force time graph is given, we can find out the impulse from the area of the force time graph. Change in momentum, area under force time graph, or integral of f dt, whatever you say, that is an impulse. An impulse changes momentum. Any force which changes momentum, any force that gives an impulse will be an impulsive force. But we are going to call impulsive forces as those forces which are forces of very high magnitude, which act for a very small interval of time and changes momentum during an impact. These forces act. Gravitation and spring force are not impulsive forces because during an impact, what you can see is impulse given by this gravitational force or spring force is very less compared to the impulse given by the impulsive forces. Normal reaction, tension, all these forces are impulsive. Depending on which case it is, we will see that case in today's class. Let us start this lecture with this one. Now, this is a question that can be done in a lot of ways, but since we are doing it, we are on the chapter on impulse and impulsive forces. We will try to do it by the concept of impulse. So this is the first question coming for you. A particle of mass 2 kg is moving with a velocity in free space. Find the velocity after 3 seconds when a constant force acts on it. I'll give you 2 minutes to give me the answer. Let me know once you are done. So, how am I supposed to do this? I don't know what you were doing, but how you need to do it is this way. Impulse is equal to change in momentum. So from there I can write the final momentum is equal to initial momentum plus the impulse. Final momentum is mass 2 into velocity v. That should be equal to initial momentum 2 into 2i minus 3j plus the impulse. Impulse is force into time, 3 into 3i plus 4j. You just have to multiply and divide. The final velocity v is going to come as 6.5i plus 3j. Please note it down. I hope everyone has understood this. Please note it down and try to see what you were doing and how it has to be done. Just apply the impulse momentum theorem and nothing else. Anyone has noted this down? Let me know once you are done. So let us move forward and let me present to you this question, question number 2. A particle of mass 2 kg is moving in free space with a velocity 2i minus 3j plus k is acted upon by a force which is given. Find the velocity vector of the particle 3 seconds after the force starts acting. I'll give you 2 minutes to give me the answer for this question, and I hope I get the correct answer. 2 minutes. Let me know once you are done so that we can go ahead. Great. I have answer 5i 5 I cap minus 1.5 j cap minus 2 k cap. That is absolutely correct. So how you have to do this? Again, I can just put the formula. Final momentum will be equal to initial momentum plus the impulse. Just have to put this formula. Final momentum is how much? Mass is 2 kg into velocity, final velocity v. Initial momentum is 2 multiplied by 2I minus 3j plus k plus force plus impulse. Impulse is 3 multiplied by 2I plus j minus 2k, and that is what we will get. You can solve this and you will get the velocity, final velocity as 5I minus 1.5j minus 2k. And that is the result that we were looking at. I hope all of you have got this answer. Then comes this question, and I hope that you can give me an answer fast for this one as well. This is the question. Question number 3. A box of mass 2 kg is lying on a frictionless horizontal ground is acted upon by horizontal force F, which varies as shown. Find the speed of the particle when the force ceases to act. This is question number 3 coming on your screens. Let me know the answer once you are done. Well done. So, how you have to do this? Again, this is the same question, but now force is given in terms of graph. Final momentum is equal to initial momentum plus impulse. How will I get the impulse now? To get the value of this impulse, I just need to find out the area of this triangle. So I think you know how to find out the area of this triangle. What is the area of this triangle? What is the area of this triangle?
Hey,
Half base into height, half 4 multiplied by 20. So I think it becomes 40. No, 20 or 40. How much?
hey, Newton second.
40, sir.
That becomes 40 Newton second. I just put the values here, and from there I can get the final velocity v as 20 meter per second. Yes or no? Anyone got this? Well done. Now let me give you this question. And I hope that you can solve this one. So similar question but just given in the form of a diagram. This one. A 100-gram ball moving horizontally with a velocity 20 meters per second. You can see this. It's struck by a bat. As a result, it starts moving with a velocity 35 meters per second at an angle 37 degree above the horizontal. 37 degree above the horizontal means this angle is 37 degrees. I hope you understand this. In the same vertical plane as shown in the figure, then there are a couple of questions. Find the average force exerted by the bat if the duration of impact is 0.3 seconds. So in first case it is 0.3 seconds. Oops. In first case it is 0.3 seconds. In the second case 0.03, then it is 0.003. What do you conclude for impulse of the weight of the ball as the duration of contact decreases? So basically we just want to understand what effect gravity has during and impact. I've already told you we neglect gravity or gravitational force. They are treated as non-impulsive force. This is just an example which I've already given, but now this is another example where we will understand that gravity is non-impulsive. So if you understand the question, you can get the answer. I'll give you 2 minutes. Let me know once you get an answer for all the cases. Once you get the answer for one case, let me know. If the answer is correct, I will ask you to move ahead. Else, you can keep working on it. We understand this? Yes or no? I'll give you 2 minutes. So, how are we supposed to do this? Impulse is equal to change in momentum. We just have to find out the change in momentum, final momentum, and initial momentum. What is the initial momentum of this ball? Can anyone tell me what is the initial momentum of this ball? You can say the answer in terms of vector. What is the initial momentum of the ball? No one knows it? Okay. So it is the initial velocity is 20 meters per second in this direction. So it is minus 20I multiplied by 100 grams. So it is minus 0.1 kg multiplied by 20I. So it simply becomes minus 2I. That is the initial momentum given by the blue thing. Initial momentum. Now the final momentum, the ball is going like this. If I can draw, this is the horizontal and this is how the ball goes with a velocity of 35 meter per second. This angle is 37 degrees. How I am going to write the velocity? I can write the velocity in terms of Vx. The x component will be 35 cos 30 cos 37 is 4 by 5. So this will become 28 meter per second. The y component of velocity The y component of velocity will be 35 sine 37. Sine 37 will be 3 by 5. 35 into 3 by 5 is 21. So I can write the final momentum as 28I plus 21J. 21I plus 21J. From there I can find out the impulse. How much will be the impulse? 25I minus 21J is the velocity. It has to be multiplied by 0.1, which is the mass. So my final momentum is 2.8I plus 2.1J. So my impulse is my impulse will be final momentum minus initial momentum. If I subtract initial momentum from the final momentum, I will get 0.8I plus 2.1J. Once I have the impulse, this impulse vector can be written as the force multiplied by the dt vector, and from there for different times you can find out the force exerted by the bat on the ball. The momentum is changed by the force impacted by the bat. What can you conclude for impulse of the weight? As what can you conclude? As time decreases, the time of impact becomes less and less. As time of impact becomes less and less, the impulse given by the bat becomes far greater than the impulse of gravity. Impulse given by the bat is far greater than impulse given by gravity, and therefore in such cases gravity is neglected. So this was the question. I'll give you 2 minutes to note it down. Once you have noted it down, please let me know. Anyone has understood this? Note it down, please. Thanks for correction. And initial impulse was minus 2I. So when you subtract it, just add it. It is 4.8I plus 2.8J. Okay. Have you noted it down? Shall we move ahead? Shall we move ahead? Okay. We have seen now once again that gravitational force, you can just note down that gravitational force and spring force, gravitational and spring force, these two forces are taken as non-impulsive. Whenever we are going to deal with an impact, and which we are going to start from the next class, we will not be taking gravitational force and spring force because they will not be creating so much of difference. What is going to create difference are the other three forces: normal reaction, tension, and friction. These are the three forces that are going to act as impulsive forces. So we will deal them one by one. The first one in the category is impulsive normal. Impulsive normal. When is the normal force impulsive and when is this force non-impulsive? Because everything depends on case to case. Everything depends on case to case scenario. And if you are just a bit careful, you would be able to understand in what case which force is impulsive and in what case which force is non-impulsive. Impulsive normal we are dealing with. We will see when is normal going to be impulsive and when will normal be non-impulsive. So here is a diagram, case number 1 that I have drawn. Two bodies, M1 and M2. M1 and M2 are colliding, are moving towards each other, and they are going to have a sharp impact between them. Now, as you can see, between these two bodies, there are three normal forces acting. One is the normal force between the two bodies which are colliding. The other two are normal forces coming from ground. The other two normal forces are normal forces coming from ground. Now looking at this diagram, can you tell me which force do you think is going to create an impulse, which is going to change the momentum in a very short time? Which force do you think are going to be non-impulsive? Gravity is always non-impulsive, so don't worry about that. We are only worried about the normal reactions. Which normal reactions do you think is going to be impulsive? Which normal reaction do you think is going to be non-impulsive? Yes.
NI is impulsive force.
And this green one is impulsive. What about this one and this one? Are these impulsive?
Non-impulsive, sir.
Very good. These two normal reaction are non-impulsive. They are not doing anything. They are not creating any impulse. They are not changing momentum in any way drastically. So these two are non-impulsive, whereas this one, the between two, is impulsive, and you can see it exists in pair. Whatever impulse this one is going to create, the other force is going to create the same impulse. As I told you, what did I tell you? That impulsive forces will always occur in pairs. So you can see the green pair. Green pair is the pair of two impulsive tensions. Do we understand this? Yes or no? Okay, this was first example where you can see impulsive forces acting. Let us move on to the next example. Next example is this one. Here also we see two impulsive forces N1, two normal reactions N1 and N2. Which normal reaction do you think is impulsive? Which normal reaction do you think is non-impulsive? Yes, my dear friends. Which normal reaction is impulsive and which normal reaction is non-impulsive? Anyone? Both N1 and N2, both normal reactions are impulsive. Both are impulsive. Why both are impulsive? Because if these both normal reactions are impulsive, this is striking this. So the normal reaction between these two is impulsive. The normal reaction coming from ground. If there was no ground, this block would have moved down, but it cannot move down because it is restricted by the ground. So this ground must be providing it with an external impulse which is cancelling the impulse coming from the top, and therefore this ground wala normal reaction also becomes impulsive. Do we understand what I have said? Yes or no? Both the normal reactions are impulsive. We understand this? Yes or no? We come to this case, case number 3. Here also you see three normal reactions, N1, N2 and N3. N1, N2 and N3. Which normal reaction do you think is impulsive? Which normal reaction do you think is non-impulsive? Two balls, billiard balls, not billiard balls because they are not of the same size. Which normal reaction do you think is impulsive and which normal reaction you think is non-impulsive? Yes,
N1 is impulsive.
N1, the pair of N1, these two normal reactions, they are impulsive. Okay, anything else? I have N2 as well, N3 as well. Which would do you think is impulsive? N1 and N2. N1 is impulsive about N2 and N3. Which is impulsive? N3 is also impulsive because if N3 was not present, this ball is hitting the lower ball like this. If ground was not there, this lower ball would have moved in this way. It is not moving, it is restricted. Therefore, this is also an impulsive reaction. But if you look at this pink one is acting on the bigger block like this, bigger ball like this. The impulse is acting like this. This ball wants to move in the air. It can move in the air. No one is stopping it. Therefore, this is non-impulsive. Do we understand what I am saying here? So N2 is non-impulsive, whereas N1 and N3 are impulsive. Looking at one last case here, that will make everything absolutely clear in your head. This one, the fourth one. Which reaction is impulsive? There is N1 reaction coming from the between the balls and there is N2 reaction coming on the lower ball from ground. Which one is impulsive and which one is non-impulsive?
Both are impulsive.
Both are impulsive. N1 both are impulsive. N1 as well as N2 both are impulsive. I'll give you 1 minute to note it down. Let me know once you are done. Everyone has understood this? Then the next thing comes, which is impulsive friction. When is friction impulsive? The scenario is very straightforward. If normal reaction N is impulsive, if the normal reaction which is creating this friction is impulsive, that implies friction is impulsive. If a normal reaction is non-impulsive, that will mean the friction will be non-impulsive. It is straightforward, very clear. It is straightforward, very clear that if normal reaction is impulsive, friction is impulsive. If normal reaction is non-impulsive, friction would be non-impulsive. Do we understand this? Yes or no? No, yes. Again, the same example. Here both N1 and N2 are impulsive. Friction created by N1, F1 and F2, they are impulsive. Here N1 and N3 are impulsive. We have already seen that. So friction created by N1, which is F1, and F3 will be impulsive. Do we understand this, or this has gone above our head saying bye bye, bye bye, bye bye? Okay, so you don't have to draw a separate diagram. In the same diagram that you have already drawn, you can just write which friction will be impulsive, which friction would be non-impulsive. It is straightforward. It's a straightforward thing. Have you noted it down? Yes or no? Have you noted it down, beta?
Yes, sir. Completed.
Then I take you to this case. Here there is a ball, big ball, which is attached to a string, and we have three cases of balls attacking it. Now, in all the cases, normal reaction between the two balls is impulsive. Do you understand this? Yes or no? Now, in case number A, case number A, case number A, the green case number A, we have already seen normal reaction. What about tension in case number A? Impulsive or non-impulsive? Tension in case number A, impulsive or non-impulsive?
Impulsive.
Impulsive. Everyone is able to understand this. Yes or no? No, yes. T is impulsive. Case number 2, pink case. B, is it impulsive or non-impulsive? Tension. Ball is hitting like this. This ball can move. Yes or no? So the tension would be non-impulsive. Do we understand this? Because this string is not going to stop it from moving ahead. Yes or no? Yes or no? Case number 3, the ball striking like this. Tension is impulsive or tension is non-impulsive? Tension is non-impulsive because tension is not going to stop it from moving. Do we understand this? Yes or no? So this is the case of tension being impulsive or tension being non-impulsive. I will give you one more scenario. Here, in this scenario, a bullet is striking block B like this. There is a string connecting block A and block B. Is the tension impulsive or non-impulsive? I've drawn the tension for you. Is the tension impulsive or non-impulsive? This tension, red tension, is it impulsive or non-impulsive? Impulsive, because when the bullet strikes, the tension is going to stop the block. Therefore, the tension is impulsive. So, in this green case, in this green case, in this green case, tension is impulsive. Do we understand this, or this has gone above our head saying bye bye? Bye bye. In this blue case, now I have made a blue case. A bullet strikes like this. We blue case, blue case, blue case, blue case. Is the tension impulsive or non-impulsive? Blue case. Bullet strikes.
Non-impulsive, sir.
Yes, because this tension cannot stop it. Tension cannot push it. Tension can only pull. So if the bullet strikes from the other side, nothing will happen. It will just move. So in this case, tension is non-impulsive. So what we have seen is whether we talk about normal reaction or whether we talk about tension, they are impulsive and non-impulsive depending on the scenario. And we have also understood in what scenario they are impulsive. We understand this? Okay, that finishes this class for today. We have taken a lot of steps. In the next class, we'll be dealing with the most important aspect of this chapter, which is collision or impact. That is coming in the next class, and I'll see you. Before coming to the next class, please revise what we have done in today's class. Otherwise, you will not be able to understand anything in the next class. Take care and God bless all of you. Bye bye.